I decided to go with a 4mm by 14 flathead screw. It's a socket head, flathead, hex head, whatever it is. But so I'll need to drill and tap for that, and then put the guide pin in here. So I'll go ahead and get that layout work done next. So I don't have a real scientific approach to how to do this layout, but it's 20 millimeters tall, and I decided to just use 6 millimeters, and then we'll just flip it over and do 6 millimeters from the other side. Then we need to scribe a line down the middle there. So I've moved the workpiece over to the edge, and then I measured the height of this center section, which is nominally 13, but it actually ended up about 12.8. So I've set the height gauge to 6.4, which is half of 12.8, of course, and then we'll just scribe our line down the middle. That gives us 2 cross points where we can drill the holes. Well, for a project like this, great accuracy isn't really required. So I don't bother using an edge finder and all that to find the center of the work. I just use my layout lines, and then this little carbide pointer tool, which has a very fine point on it, and with my magnifying glasses I can get in there pretty close and get that to where I want it. And sometimes I'll just bring that tip down a little bit and make a little dimple there to see if I'm on. And in this case I'm just a little bit off, so I'll move it and try again until I get it where I want it. Unfortunately, from doing that over quite a few years, the tips on these pointers have gotten a little bit dull, so they don't work quite as well. I tried sharpening them, but they're carbide, I guess, so didn't have a lot of success with that. I haven't been able to find any new ones. I got them as part of sets of those very tiny drill bits you can buy. Alright, so now that we've established that reference point, I went ahead and set the DRO to 0, and then we'll use the x-axis to move over here 8 millimeters, I guess it is, for the second hole. But this first one will be the drilled and tapped 4mm by 0.5, I guess it is. So I have to get my drilling and tapping stuff set up here. So go ahead and drill and tap this 4mm by 0.7. I can just put a tiny drop of Tap Magic aluminum on there, and we'll come in with the center drill. The screw that we're going to use is 14 millimeters long, but about 7.5 of that will be taken up by the cover. So I'm only going to drill this about 10 millimeters deep, and that will give clearance for the tip of the tap, which of course does not form threads all the way down full size. Put a little more Tap Magic on there. You got to bring it down to here, and I'll set my Z-axis DRO, use that to measure the depth. Use peck drilling to clear the chips out. I think I'll put a little more Tap Magic down in there. Okay, we're at 10 now. So my standard tapping setup for the mini mill, I use this little shop-made spring-loaded tap guide, and that just helps to ensure that the tap goes in square and straight. So the tap guide goes into the drill chuck, clamp that down. This movable point maintains pressure on the tap wrench. Most tap wrenches have a little conical hole in the top for this purpose, or I assume it's for this purpose. So we'll get our tap wrench up in there. We need to raise the head some. And now we've got pressure on that from the spring. So we'll put a little Tap Magic on there. And away we go. With aluminum especially, it's important to reverse your tap every couple of turns to break the chips off. Otherwise they tend to get bound up on the tap and you don't get good results. But this Tap Magic aluminum or a similar tapping fluid works well to help chip buildup or help prevent chip buildup. And if you're going pretty deep, and this is a somewhat deep hole, it's sometimes good to back the tap out and use a little compressed air to clean it out before you get all the way down, because this is a blind hole. There's nowhere for those chips to go, so they tend to bunch up at the bottom and can cause problems getting a clean thread. So I'm going to go ahead and remove that, and we'll blow a little compressed air in there. This can be very low pressure air. 10 pounds is probably plenty. I've got it set to 30, but I'm not using nearly that much. But you don't want to use too much, or you get chips and fluid flying all over. It can get back and hit you in the eye or get lodged somewhere else where you don't want it. I'll take the brush and clean these extra chips off of here and go back in and complete that hole. And of course use some more cutting fluid. The tap guide not only helps keep the tap square, so you get a square hole, it helps protect the tap from being broken if you accidentally put sidewards pressure on the tap handle. But also for small diameter taps, and this one's pretty big so it's not an issue, but on real small diameter taps, when you get down to 2 millimeters and 3 millimeters, it helps protect the tap from being broken if you accidentally put sidewards pressure on the tap handle. So it's a handy thing to have. They're relatively easy to make, and for many years I had a project on my premium content on minilathe.com. That was one of the projects, was making a tap guide, but maybe I'll do one on video before too long. Maybe someday. We'll blow the chips out once again. A lot of times I like to use a rag when I'm doing this, and that just keeps the chips and fluids from going all over the place. That's a good practice, but I don't always do it. Now we'll move over 8 millimeters and drill our second hole, and that will be a piece of 1/8 inch diameter drill rod that will serve as a guide to keep this T-nut from rotating as it goes into the T-slot. You'll be able to see better how that works when we get it all done. So I'm watching the DRO now, and we'll just crank over here. Let's get the center drill down there. And of course, on a project like this, there's nothing really critical about the spacing, but it's I try to use some sort of logical units, because sometime in the future I might be trying to figure out what I was doing and why. And if you use arbitrary spacing, that can lead to some head scratching. Sounds like that center drill was a little off center in the chuck, which sometimes happens. This is a decent chuck, but it's not a great chuck. Every once in a while it grabs a drill bit so that it's not totally on center, but no harm done in this case. I'm going to press fit the piece of 1/8 inch drill rod into this hole, so I want the hole to be just about 1/1000th or so undersize for 1/8 inch. So that's 0.125, so I want the hole to be about 0.124. And to do that, we'll drill it undersize by a 64th, because that's the next smaller drill below an 1/8 in a standard set. And then we will go in with a reamer, which is called an under reamer, which is 0.124 in diameter, and that will make a hole that's slightly undersized for 0.125. So when we press our drill rod in there, it will have a very tight fit. Well, the drill size, the next smaller size from a 1/8 is 7/64. So we'll go in with that. We'll go to a depth of about 10 millimeters. The depth isn't critical, but I just want to have enough clearance so I can press that pin down in there. Well, I stopped at about 8. That should be plenty. The pin is going to stick up about 7 millimeters above the surface, and we'll cut it. We'll make it about 14 millimeters long, so I'll have about 7 below and about 7 above. So I'll get that pin made up. Well, down here in the reamer drawer, I have this set of over and under reamers, and just to give you an idea what they are, you get these are in increments of a 1/16 of an inch. So it starts out, the smallest size is an 1/8, and then 3/16, and then 1/4, and 5/16, 3/8, and so forth, up to a 1/2 inch is your maximum. And for each of those nominal sizes, for example, for 0.25, you get 2 reamers. You get one that's 1,000th undersize, which is 0.2490, and you get one that's 1,000th oversized, which is 0.2510. So you don't get it 0.2500 because those are typically you have in a separate set. But what you use these for is, in this case, we want to do a press fit. So we're going to choose the reamer that's 1,000th undersize. But let's say we wanted a shaft that was going to rotate in a brass bearing or a brass bushing. So we drill that bushing out to 0.25, a little under 2.500, the next smaller drill size, and then we would ream it to 0.2510, so that our shaft, which would probably be, say, 1/4 inch drill rod, which is accurate to 1,000th of an inch diameter, would turn freely in that brass bushing. So for this immediate need, we want to do a press fit on a 1/8 inch diameter rod, so we're going to choose the 0.124 undersized reamer. The reamers, like drill bits or taps, have precision ground cutting surfaces, so you want to protect those. You don't ever want to throw these in a drawer loose and banging together, or it'll quickly ruin these surfaces and they won't function as they're intended. That's why they're individually have individual sleeves in this wrapper. So a reaming operation is pretty similar to drilling, but there's a couple of important differences. One is you always want to use cutting fluid so you get good chip clearance. Second is you don't use as high a speed or as high a spindle speed as you would for drilling a hole of the same size. I've never come across a good rule or even an explanation for that, but it has always been my inclination to run the spindle speed at about half or even lower of the RPM that you would use for the same size drill bit. So I'm going to run this pretty slowly. And the other precaution is don't ever turn your spindle in reverse when using a reamer. They only go in one direction. If you run them in reverse, you can damage the clearance edges and effectively ruin your reamer. So always go in the direction that it's intended, which is clockwise, looking from above. So we'll just come in slowly and steadily here, and it will clear the chips out. Now if you have a real deep hole, you may have to go in and out a couple of times to give the chips some room to clear out. But we're done. So that's all there is to it. Then you want to clean your chips off and carefully put it back in its protective sleeve so it doesn't get those precision edges damaged. Well, over here on the other side of the shop is the bar stock storage area, and these are, I glued some plumbing drain pipes together just using PVC solvent, and just stacked up in a triangular fashion. These make a pretty good storage unit, and I've been using them for years, and even though this metal's pretty heavy, they've held together well, so it's a convenient way to store them. And then I have the ends here accessible so I can look in and find a rod of the diameter that I want, in this case an 1/8 inch drill rod. And here's a piece that we can use, and we'll cut off what we need, put the remainder back in here. When these pieces get down to, you know, about 8 inches or less, instead of putting them back in here where they tend to get lost, I keep them in a drawer over by the mill. The storage bin is more or less sorted by material type. So I've got 6061 aluminum here, and then this is all drill rod, then some key stock and other steel bar stock down here, all thread, And down here we've got some steel and maybe a little stainless steel, and then various plastics, mostly acetal or Delrin is the trade name. Some aluminum tubing and channel and some plastic stuff. So it's not a foolproof system, but it works pretty well. I need to cut off a piece about 14 millimeters long. Cutting this relatively thin bar stock is always a little bit of a problem. Sometimes I just use an abrasive disc on a Dremel, and other times I'll stick it on my horizontal vertical bandsaw, and it will also do a pretty decent job at cutting it. And I guess as a last resort I use my stand-up bandsaw, but it doesn't handle things like this very well. Well, in my shop, probably the quickest and easiest way to cut this is over here on the horizontal bandsaw. Another way you could do it is, of course, put it in a lathe and cut it off with a little cutoff tool, but you would need a relatively small cutoff tool to do the job. I like to use the bandsaw because it's always here and ready to go. It just takes a second. Oops. Got busy talking and forgot to line it up where I want to make the cut. So let's move it down a little bit and try again. I'm actually holding the arm of the bandsaw by hand and just lowering it manually so I have control over it. Now, of course, if I had not been hand holding it, it would have cut through there in an instant. So I wanted the better control I can get by lowering it manually. By design on my bandsaw setup here, my fancy bench, I can just pull this tray out. So when a piece falls down into the tray, it's easy to retrieve. After I cut off a piece of bar stock, I like to take it over to the disc sander here and just lightly chamfer the edges. So when I put it back in the bin, I don't have sharp edges on here that might cut me when I'm probing around looking for a piece of stock in the future. So that's all it takes, and now we've got a fairly clean edge on there along with my little misplaced cut. Well, now we've got this little piece of 1/8 inch drill rod, and I want to put it in the lathe and clean up the two ends and round one of the ends so it can serve as a guide pin. But the 12-inch lathe is a little bit overkill for this job, so we'll take it over to the mini lathe. So it's really nice having a choice of lathes to use. So the mini lathe still gets plenty of use in my shop. I wouldn't say necessarily on a daily basis, but certainly several times a week. I do probably 80% of my work or 70% of the work over on the big lathe. But for these small jobs, it's really nice to have the mini lathe. There are also a lot of times when I have something dialed in on the big lathe on the DRO, and something comes up where I need to do a quick cutoff or turning job or something. I can't move the whatever's in the big lathe, so I just bring the piece over here and do it here. Or if you happen to be doing modifications to the big lathe, you can make the parts over here on the small lathe, or vice versa. Sometimes I'm making modifications for the mini lathe, and I'll make the parts over on the big lathe and bring them over here. But that's a luxury. I've been doing this for 20 years consistently without interruption, and I actually started working with lathes 50 years ago, so I've had the luxury of being able to accumulate some tools over that time. So for this first operation, I'm just going to face the end on this, and I'll take a file and clean up the corners, and that will be the bottom part. And I'll put a little chamfer on there with the file just so it will go into the hole more easily, and we'll press it in. And then on the opposite end, I'm going to round it, because that will be sort of the tip that acts as a guide in the table cover. So let's go ahead and get that done. Well, that's probably good enough for what it is, but just to demonstrate the technique, I'll use a little wet dry sandpaper to smooth it off even more. You have to be very careful working up close to the chuck though. Okay, I think we'll call that good enough. Alright, so there's our little pin, and what we want to do now is press that down in that hole. I think I'll take a deburring tool here, put a little chamfer on this hole, and that will help it to go in a little more easily. So this end will go in, and then this rounded end will be sticking up. For deburring, I'm just going to use a very low RPM and some light pressure. That's all it takes. To get the pin started in the hole, I've just clamped it tightly into the drill chuck, but it will probably slip. There'll be too much force involved, most likely, to try to push it in very far this way, but it's a good way to get it started and aligned. Yeah, and now I'll loosen the chuck, and we'll use another method to press it in deeper. See if I can get that loosened up there. Now we can get the chuck out of the way. One thing I could do is just close the chuck jaws down, but I don't like to exert that much pressure on the tip of the chuck, so we'll use some other method. In a case like this where the pressure required is probably not real great, I'm going to try using a transfer punch, and I've mounted the transfer punch in the Jacob's chuck, or Jacob's style chuck I should say, with the flat end down. So I'm just using this as a pressing tool, and it will probably be enough to do the job. So let's give that a try. And if it's not, no, it's it's actually bending, so I guess I was wrong about that. So we'll need to use some other method. So I found this piece of scrap material in the drawer below here, and we'll try that. It's got a little dimple on the end that will fit right over that pin, and we'll put that in the drill chuck and see if it'll do the job. Just for good luck, I think I'll put a drop of oil down here. That might help it to slide in more easily. But let's put some force on it and see how it goes here. It's still not going in. Well, I'm surprised it's requiring that much force. I wonder if I made the hole too small or something. But, well, let me think about this a minute. I don't know if you could see it, but it looked like it actually tilted it over a little bit to the right. So I don't want to, push it down in there and have it gouge a hole and not be straight. Other options that we have available, I could take it over to the SX4 mill, which is a lot sturdier and more robust than the mini mill. I could probably get the job done there, but let's go do it the old-fashioned way. We'll just take it over to the vise and see if we can squeeze it and get it in that way. The big problem with the vise is you don't have any control over whether the pin goes in straight or not, but hopefully the hole itself will guide it in the right direction, so we'll see. Well, this is my big shop vise here. I got this at Costco probably more than 20 years ago now, because I got this before I got the mini lathe, but it's done a good job for me, and it's got plenty of strength for the things I do, so we'll give it a try, see what happens. Yeah, that pin's definitely tilted, and I think I want to try to straighten that out before I press it in any farther. So we're back over at the mini mill, and I've clamped the workpiece tightly in the vise, and I clamped the pin tightly in the chuck, and now I'm going to lift up, or I'm going to raise the chuck. Hopefully it'll draw that pin out, but we'll see. Aha, it did. I don't usually have this much trouble just pressing a simple pin into place. I'm not exactly sure what's causing the trouble. This is drill rod, should be accurately sized, but let me check the diameter just to be sure. It's possible I do have some odd size stock over in that bin that's it looks like an 1/8, but it could actually be some metric size or even some other size that I got for some special purpose, so let me just double check that. Well, it's pretty close. It's just a hair over a 1/2 thou or 6/10 over 1/8 of an inch, so that's within spec. And by the way, the reason I use drill rod for this is because the diameters are accurately sized within 1/1000th of an inch from the factory. So it's a good material to use when you want to fit it in a hole of a specific size. Given the circumstances, I think what I'm going to do is we started out with a .124 reamer, but because this piece is actually a little over .125, I'm going to go back in with a .125 reamer. Maybe that will solve the problem. So let's give it a try. Worst case is it'll make it too big and then we'll have to Loctite it in, but that's okay for this application. Oh, and incidentally, if you don't have over and under reamers, that's a good solution if you wanted to make something like this. Just ream it out to 125, press it in, and if it's a little loose, or even if it's not a little loose, you just use some Loctite or a similar thread locking compound, and that should do the job. As I mentioned, the over-under reamer set doesn't have a .125 reamer, but for all the standard sizes, I have separate reamers that I use. So this is a .125. Now, one thing we have to be careful about is because we've removed the workpiece and put it back, the alignment is no longer guaranteed. It should be okay front to back because this was machined so it's symmetrical. So either way I put it in, it should be okay in the y-axis, but I'm going to loosen the vise, and then we'll just gently lower this down, and that will help it to self-center on the reamer. And now we'll tighten the vise up. Okay, well, we've got our T-nut built, so let's see if we can get it installed on here. So we've got to decide where it's going to go, and my inclination is to put it probably here. Could go either here or here, I guess, more or less central. But this T-slot is in line with the clamp. I don't know if that matters, but I think I'll put it here and we'll see how it goes. As I mentioned earlier, I may find that I have to add a second one. And so it may be a process of trial and error, but we'll see.